Thank you, Mike. So we at the Hub get many questions about this topic. So we have partnered with the New Buildings Institute and Arup Engineering to deliver this session that explains the overlay and also makes some experts available to you to answer your questions. My name is Teresa Backus. I'm the Associate Director of the Building Innovation Hub. You'll see some other folks from the Hub here with me, as well as representatives from NBI and Arup who will be introducing themselves in a minute. So before we start, a few quick housekeeping notes. We are planning to save some time at the end for Q&A, but please do feel free to put questions throughout the presentation in the chat. We'll monitor it as we go. I'll probably be interrupting the speaker now and then with questions that are pertinent, and we'll also do our best to answer all of the questions in the chat. You can please, if you could please keep yourselves on mute, but feel free to unmute yourselves when it comes time for questions. I will be sure to drop our contact information in the chat. You'll see our website as well on one of the slides towards the end of the presentation, but we'll be recording this as you saw earlier and we'll be posting it. We'll also be following up with you via email afterwards so that you have all of the information. So without further ado, I want to introduce Linda Toth, Associate Energy and Sustainability at Arup. Arup is a Hub member at the transformer level and has been instrumental in helping us create the resources and events like this one to help DC buildings and the industry at large. So we're thrilled to have Arup as a supporter, and I'll turn it over to Linda for more.
Thank you, Teresa. Great to be here today and for our partnership we've had since the beginning of the Hub. For those of you that may not know, Arup is a global engineering and consulting firm. I have the pleasure of leading our DC team for energy and sustainability related matters for all things building, infrastructure, and consulting. So we get a lot of questions that we're now able to use the Hub as a resource for to help find solutions. But Arup internally works in a very regional, collaborative manner. We work to share lessons learned and solutions that we're finding in partnership with New York, for example, of how they're working with Local Law 97, how Boston's now looking at their new carbon performance metrics, because we understand there's really great pushes around new construction building codes and how we can make sure all of the new buildings that we're building to meet demand can have really high performance standards, but over 80% of the buildings that we currently live and work in are still going to be around and be in use by 2050. So it's going to be really important that we find better solutions and better ways that we can have really high energy efficiency and zero carbon solutions. So we're really excited that we've been working with the Hub since it was initially established through the DC Department of Energy and Environment, and it became very clear when we were working with the team from IMT and what is now the Hub that the gap was there in the market, and we needed this resource to help all of the AEC industry find the solutions that we need to meet the regulations that the district was putting out there. The other really exciting thing from Arup's side, COP26 is going on. Hopefully you've heard some of the exciting announcements going on across the world related to that. And I'm excited to share yesterday, Arup announced as of April of next year, we're going to be performing a whole carbon life cycle assessments on all of our projects because we need those metrics to be able to compare the performance of our buildings internally so that we can explain better to our clients and the people making the decisions about where dollars are being spent to get the best solutions for whatever their biggest challenges are. So working with the Hub and thinking about how we get clients to shift the way they typically design and operate buildings, we need better data to be able to point to the solutions that we know are going to work for the specific situation that they're in. We've had the pleasure of getting a little preview of today's presentation. Kim has done this presentation specifically for Arup's DC team. So we got the one-on-one session and got to ask direct questions from part of our membership, and it's been really helpful to move the needle and get our staff really engaged on how BEPS can help the existing buildings in DC. So with that, I'm going to hand it over to Kim, and she's going to take us through the rest of the session.
Great. Thanks, Teresa. Thanks, Linda. Glad to be here with you all today. Again, my name is Cheslak. I'm Director of Codes at NBI. Just a real quick run through of what we're going to be talking about today. Sort of an overview of DC building codes and building energy performance standards, looking at what that means for new construction, key considerations, challenges, and opportunities between matching the code and the building performance standards, maybe some options for what long-term planning for those design decisions look like, and tools and resources that already exist through the hub and through others. And then we'll leave some time for discussion and Q&A. This is largely built off of a resource that we made from the hub or for the hub a little over a year ago. So like AirUp, NBI was also a founding partner engaged with IMT in the development and standing up the hub. So we are also excited to continue to be a close partner for what's going on in the district. And I think we've got some polls, and I'm going to be honest, I'm not sure how, or were we going to run these through Zoom?
We can, but we weren't planning on sending a formal, polling. So maybe just put it in your answers in the chat.
Yeah, so just, getting a sense of who's here with us today, different, engineering, design, project teams that we know are operating around the district, sort of get a sense of who's with us and why you're with us. And if we've obviously missed anything, the other, feel free to jump in with what you've got there.
Yeah, I will say if there's anyone else that we didn't capture in the list there, please feel free to put your specialty in the chat.
Great. So I think that this group probably knows the importance of focusing on buildings globally. Emissions from buildings and building operation represents close to 40% of greenhouse gases, but in urban centers like DC, where there are more larger buildings and more public transportation options, buildings represent a much larger share. And we can see that in the district, this is 71% of emissions come from buildings. Under Clean Energy DC, the district is committed to reducing annual greenhouse gas emissions and energy consumption by 50% and achieving 100% of its energy derived from renewable energy resources, all this by 2032. Additionally, in December of 2017, Mayor Bowser further pledged that the district would be carbon neutral by 2050. 30% of the projected greenhouse gas savings by that timeframe will come from building-related initiatives, specifically actions that require efficient carbon neutral new construction and expansion of deep energy retrofits. Exactly what we're talking about today, the combination of new construction codes and building performance standards. The effect that the district and other jurisdictions, including now the federal government, in setting these sort of targets and goals has put an additional emphasis on talking about emissions in buildings, meaning that things like building codes and building performance standards are becoming mainstream and people are more aware of the impact that our buildings have on climate. We know that DC is already ranked as a top market for delivering high performance buildings. CBRE's annual report ranks DC and Northern Virginia second and fourth among top 30 cities in the country for green characteristics in multifamily buildings and 10th in office buildings. So not only now is the regulatory infrastructure in place to require high performance buildings, the market is used to looking for these criteria already when buying and leasing. So building owners who are asking for what their customers are demanding are going to increasingly be seeking those high performance solutions in buildings that they're purchasing or constructing. And we'll just skip past that one quick too and dive in here. So quick overview of where we are with DC codes and BEPS. So this is just a graphic that the hub has put together showing the regulation and governing of each stage and activity between design and operation of a building. So we know that the DC Energy Code applies to buildings as they're being planned and constructed, and that benchmarking and BEPS laws apply as soon as the building is delivered and reaches an occupancy threshold. A new building becomes an existing building as soon as it's built. So if you're required to benchmark, you need to start benchmarking the calendar year after receiving your CO. And once a full calendar year of utility data can be collected. After a full year of benchmarking data has been reported, a new building will be required to meet the standard at the beginning of the next BEPS period. So this will be slightly complicated if we're talking about multiple buildings, but if you map a single building that you're constructing against this, then you should be able to map out those calendar years pretty succinctly. DC Energy Code, right, in that first step. So the DC Energy Code is a package of new construction codes that govern what's required in our new construction. Energy Code provides specific requirements for energy using systems in the buildings. There are 3 paths in the Energy Code: the prescriptive path, modeled performance path, and alternate compliance paths. Today, we're just going to focus on the first 2, the alternate compliance paths, because they involve third-party certification. We're sort of out of the scope of this discussion, but the same types of application and consideration in either modeling or selecting prescriptive requirements could be applied to those paths as well. At the highest level, the new Energy Code, the 2017 DC Energy Code, is built on top of 90.1, 2013, with amendments that were derived from the previous version of the Energy Code amendments that had been in place, as well as ASHRAE's 189.1, focusing on the energy consuming portions of that. And the previous DC Energy Code was built on the 2012 IECC, again, with some significant amendments. The biggest thing to note in terms of building performance standards here is that when you compare these 2 Energy Code pies, what you'll see is that between the 2 code cycles, there's a 3% increase that I want to note in equipment. And this is equipment and plug loads. And as much as we can control lighting, water heating and air conditioning and ventilation in design, there's little to almost no way to control users during the design phase. So this, what was 37% and is now sort of 40% nationally across all buildings, is a really big opportunity for BEPS compliance that's going to have to happen after construction. So the next piece along that timeline, benchmarking. DC was the first jurisdiction in the country to pass the benchmarking ordinance when it adopted the Clean and Affordable Energy Act in 2008. The law requires that large privately owned commercial and multifamily buildings and district government buildings benchmark their energy and water consumption using Portfolio Manager, reported to DOE annually, and then the data is disclosed publicly. And they have put out a series of maps so that you can sort of track Energy Star score by filtering by different metrics and to compare yourself to your peers, or just understand where your building is, or if you just love maps. Similarly, the building performance standard thresholds have been built into sort of an interactive interface. So BEPS is a minimum energy performance target for existing buildings that is legislated to be no lower than the local median Energy Star score by property type. Oops, went too fast. The district has, again, sort of like I said, published this map. You can dive in. Right now, we're highlighting DC Hubs building, 1707 L Street, office building constructed in 1960. The median Energy Star score for office buildings we know is about the score of 71. And this building specifically had a score of 84 during the baseline year of 2019. So by exceeding or meeting that Energy Star score, this building is considered compliant during this first cycle of BEPS and does not currently require any additional action. Okay, so how are we going to try to figure out where the new construction might hit on a building energy performance score? What NBI did to try to figure out if new construction would sort of be guaranteed to meet the building performance standard is we did 2 analyses. First, we took the benchmarking data from the district and sort of scrubbed it for data that we thought was usable. So if you all have been benchmarking, you know that sometimes things get misreported. So we sort of tried to take out buildings that we thought were either misreporting or had been missing a meter or something like that. Based on, having worked with some of this data before and just other pieces of analysis. And we mapped the site EUI, the source EUI, and the Energy Star score of those buildings. And so this graphic shows multifamily buildings that we think were built under the 2013 Energy Code. And the way we chose that was we picked a construction date sort of as a proxy. So construction dates between 2015 and 2017 were selected as that proxy when we completed this analysis. And this is what it looks like. And so what this graphic shows is that, broadly speaking, there's an inverse relationship between site EUI, source EUI, and Energy Star score, which we sort of expect because the Energy Star score is meant to estimate energy performance of a building, normalized for weather and other building characteristics. The lower the energy use, the higher the Energy Star score. And this is what happens when you look at it as a trend across multiple buildings. Although there are a few outliers, right? Building I here is very high source EUI and is sort of tracking in that median Energy Star score, right? So this line here is the multifamily target, which is 66 for this first compliance period. And so you can see buildings that are going to be meeting it and buildings that may not hit the target based on the old code. So then we took the same look at office buildings, right? So as you saw before, site EUI, source EUI, Energy Star score, and mapped it again sort of against that 71 that we know is the target for office. And we can sort of look at a breakdown, right? So 71 in office, 66 in multifamily, you end up with 1 non-compliant office building, 9 compliant office buildings, 21 compliant multifamily buildings, 8 non-compliant multifamily buildings. So this is not a statistically valid sample. It's just the sample that we have. But what this works out to is about 90% compliance in offices, right? 9 and 10, and about 72% compliance for multifamily, which is a little bit more concerning. Then we dove into the Energy Star considerations, right? So the Energy Star score is based on an equation. It includes number of dwelling units. It includes the number of bedrooms per unit. And it includes a little bit on fuel use. So your fuel use will impact your score, whether it's derived from natural gas, electricity, or on-site solar. All of those will change the score that you have. So again, this is that same graph that I showed you before. Again, target that BEPS median of 66. And then we ran a test against what we thought the 2017 Energy Code would deliver. This is based on analysis that was completed by PNNL. And instead of looking across multiple buildings, because we did not have multiple buildings at this time, we took the PNNL analysis and we changed the variables that Energy Star uses to normalize its scores. And what we got was a variety of scores that may apply to a code constructed multifamily building. You can see here, again, this is the 66 that we're sort of looking for. And we have a range of scores of 55. So we go from a lowest score that we were generated was a 28, and the highest score we generated was the 83. Just by adjusting the factors that Energy Star uses to normalize its data. So really quickly, what we did was we did a couple of things based on the PNNL assumptions that went into their analysis. So the size per unit, how many bedrooms. We use also a series based on Energy Star defaults, which we do not recommend you do for design characteristics, right? But for this type of analysis, it made sense to sort of change those variables. And then we also broke down the DC data. So we used the DC data that exists, what was sort of a low number, a median number, and a high number in terms of size of unit and number of bedrooms per unit. And just if you were sort of wondering, this is the energy data that we used based on that PNL analysis. So we used electricity from the grid, electricity from solar generation, and natural gas inputs. Then we went through a similar piece with offices. So Energy Star considerations for offices are a little bit different. Obviously, there's no bedrooms, there's no units, but they have weekly operating hours. They have an occupancy number and a number of computers, which sort of plays into that plug load conversation. And then again, fuel use. So now we're targeting that Energy Star score of 71. Again, this is the existing buildings that we estimate were built to the 2013 DC Energy Code. And we ran a very similar type of analysis to try to estimate for offices what the scores might be. In offices, we ended up with ranges that were much tighter together based on those variables present in the Energy Star calculation. So we ended up with a range of 16, and the scores varied from 70 to 86. Quick review of sort of the estimates that we're looking at here. So we took the PNL assumptions for operating hours and the number of square feet per person. And then we took the DC data, low, median, high. The other piece that I will caution here is square foot per person. We sort of started this analysis at the beginning of the time of COVID. And so we know that this variable specifically may not look the same going forward as it has looked in the past. But at the time of the analysis, we decided that instead of speculating about what office allowances would be for square foot per person, we would just use the historic DC data. And the market will sort of need to sort itself out, and this variable will need to be taken very seriously if there's a dramatic shift in the square feet per person that are allotted in new office designs. Again, this is the energy use we were looking at from PNL, electric from the grid, electric from solar, and natural gas components making up that analysis. So what we ended up with in this very hypothetical analysis is 13 compliant office buildings, 2 non-compliant office buildings. The asterisk on that 13 is that one of the office runs was exactly a 71. So that building would be compliant for this first 5-year cycle, but may not be compliant in a second 5-year cycle. So just sort of flagging that. And then in multifamily, again, the results are a little more concerning. So we have 18 compliant runs, 11 non-compliant runs that would happen in the multifamily. Overall, we think that it is highly likely commercial office buildings built under the current code, the 2017 DC Energy Code, will meet the thresholds for BEPS compliance in the first BEPS period. It's obviously not a guarantee from the numbers we just showed, and it is quite possible that a code minimum would not give you for compliance in the first round of BEPS. It is also likely that then long-term, as the standard were to change, that office building may become non-compliant. Residential, it is less certain. These multifamily buildings have a lower degree of certainty that you will build to code minimum and meet BEPS even in this first cycle. The range that we saw as, based on those Energy Star calculation and standardization is sort of concerning. And so we really would recommend that residential buildings look very closely at design and construction considerations that they are taking in that happen at, initially in that first cost towards a long-term compliance to BEPS. 30% of those buildings that we hypothetically analyzed would not be compliant.
Hey, Kim, we have one quick question I want to
Yeah.
talk with. So the question is the PNL analysis based on the future building meeting the 2017 code via the performance path or the prescriptive path? And I think what you were referring to is it just currently is achieving the minimum Energy Star score, correct? So would not be falling into a compliance path?
So I don't think I understood the end part of what you just said there, Teresa, but the PNNL analysis that was done for DC is the same way that PNNL does analysis for the national model codes. So they take into consideration sort of an average building. So there's no one prescriptive path, right? You can use the prescriptive path of the code to build thousands of iterations of the exact same building, and they would all be code compliant. So it tries to assume that some variation of each of the paths will be built, and what would an average building built to these conditions show. It's also based on the PNNL model prototypes. If people are familiar with those, they did amend them slightly for the district because unlike when they do a national analysis, there is less variability in DC's buildings, smaller footprint. We sort of know the building stock that exists and have a good sense of the building stock that is going to come online. So there were some tweaks made to make the model prototypes more like DC's buildings. I don't know if that answers this person's question.
Okay, thank you.
Sure. Or whoever asked, feel free to tell me I did not answer your question and dive
It
into
looks
the next
like,
round.
yes, it looks like it did answer your question.
Okay, great. So I know this is part of why you guys are here. What is the role sort of the engineer designer then in BEPS compliance? And so this is just guidance from us, you know, unlike building codes, because BEPS regulate the actual performance of a building, there need to be multiple people that take responsibility for what that compliance looks like. Except that, like we said, as soon as a new building becomes an existing, as soon as a new building is built, it becomes an existing building. So we don't want to set up our new construction to immediately need to change in relationship to its real world performance. Taking on sort of additional work after a building is just complete may be out of the question. So we recommend that designers sort of try to take into consideration how to maybe predict or future-proof these buildings against future compliance cycles. There are specific things that we know can be done that are the same things we've talked about in energy efficiency for years. Envelope optimization, high efficiency heating and cooling systems, so not the federal minimums, and integrating a lot of modern control systems so that the building is able to be operated very well. It's not just about how good the system is itself. If the building can't shift or change in relationship to an operation need, then you haven't set up a building that is going to be strong in BEPS compliance. All right, dive in here a little bit. We'll talk a little bit about prescriptive path considerations, model performance path considerations, and then I'm going to mention again, unregulated loads are a very large piece of the puzzle here. The energy code does include some load regulations. There are some requirements for, like in offices, having plugs that are, you know, can be automatically turned on and off. And DC has gone out of its way to understand how things like requiring Energy Star appliances can help reduce those plug loads, but it is still a large load in the building that's going to have to be dealt with sort of at that user level. But prescriptive path considerations, I just said this, I said thousands of iterations, but my slide notes here say two buildings using the same energy code following the same prescriptive path can have wildly different actual performance outcomes. It's because the prescriptive path isn't a single path. It's sort of a choose your own adventure through a series of prescriptive measures. And so you can have two buildings that both have less than 30% window to wall area, but one of them has, you know, 1% and one of them has 29%. Those buildings are going to operate very differently. So trying to optimize that envelope, you know, dealing both with window area, dealing with the materials that you're selecting. So what is the R value of the walls you're installing? What is the air leakage of the building that you are building? All of those things are going to be really strongly tied to long-term performance. We know the envelope isn't going to change much over its lifetime. And so getting those decisions right at the outset is really important. System type. The prescriptive path considers all HVAC systems equally code compliant as long as you meet the federal minimum efficiency. Well, we know that you can buy different efficiencies in things like furnaces or heat pumps. And so how you select the most efficient system for your building is also going to have a pretty long-term impact. We expect that those systems last not quite as long as the envelope, systems anywhere from 20 to 25 years. Hopefully your envelope lasts for 100. But that 25-year period is going to take 5 BEPS cycles. And so how are you setting that system selection up to have the best performance over those cycles? Again, commercial energy code has sort of the same requirement for all non-residential buildings in terms of internal loads, but the energy outcomes can vary a lot based on building height, occupancy density, which would all sort of affect how much you would need to condition the space. And we also know that these things are also factors in that Energy Star score, right? So what is the occupant density? How are you designing for that? What does that mean for the code? What does that mean for BEPS considerations? It's not the same answer to each of those questions, right? For code, it means how much heating and cooling do I need? For Energy Star score, it's how they're normalizing you against other buildings. And then there's a lot of design decisions that are not addressed in code. How you mass your building, the geometry, the orientation, site exposure. A lot of these in the district are not particularly fluid. You guys are sort of generally on a grid, so you're not going to be able to, massively spin your building around to find the right solar optimization, but there are potentially some areas for design that the code will not consider. All of those can also be taken into the performance path. I want to be very careful here to remind people that the performance path is a comparative model. It is not a predictive model. All it does is say, if I built this building and I compared it to a very similar building that met code, the code prescriptively, do they use about the same amount of energy? Neither of those buildings is a real building. And so the performance task is not meant to be predictive. Although I will then say that if you're doing a performance path calculation, you should consider, as you go through those modeling exercises, starting to plug those into Energy Star Target Finder, because it will give you a better sense than no sense at all of what your Energy Star score might be. You may, as you're working with engineering teams like Arup and others that have done a lot of building construction, ask them to go back and say, okay, well, do you have data from any of your other previous buildings? Do you know, what are the actual plug loads that are in place? And can we plug that into a target finder assumption, as well as the data that we're getting from the predictive, from the compliance modeling? And so using that as an iterative process will be able to help you ensure that you're sort of on track. It is not, again, not a guarantee. Building operations and operating schedules are really going to be important in the performance path to meet code compliance. And you should try to tailor those in some way to get an energy output that is as close to being predictive as possible. It will not be accurate. Proximity to a weather station, we know, impacts how the model will react. And then, quite frankly, quality and accuracy of the person doing the modeling can also produce wildly different results. So I always recommend that people work with modelers maybe that they've worked with in the past. I would say, as a previous code official, if you're getting a lot of comments back from your code official on the modeling, then there's probably some more errors in there than you would otherwise expect. Then additionally, the performance path, because like I said, it relies on a baseline building. The baseline building it depends largely on the type of building. And so you can have a lot of ranges within the baseline you're comparing to as well. Window to wall area ratio for that baseline building is anywhere from 6 to 40%. Since we spent a lot of time talking about office and multifamily, the HVAC system baseline is also important. Office uses VAV system, multifamily uses PTAC. Both of these will impact energy cost, which is what the performance path is about, but is not what your Energy Star score is about. Same for surface water heating. Office uses an electric resistance baseline. Multifamily actually uses a gas baseline. We'll talk more about that in a second. And then the schedules. Again, the schedule of your performance path building is going to be the same as your proposed building. So that schedule is not going to impact your code compliance, but it is going to impact your Energy Star score. The same for those plug loads. Not going to impact your performance path. Code compliance is going to impact your Energy Star score. So knowing that these variables and how they fit in and are different, hopefully will help you guys sort of steer through what to do. Talked a little bit about this before. So we'll sort of, I think, move forward here. One thing that I'd like to flag specifically, because we're going to dive into a little bit of a look at a multifamily building under consideration, is that fuel choice. I said this before, but I want to drive this home. Fuel choice will impact your Energy Star score. And so understanding what it means to select an electric system or a gas system or provide on-site solar, which is now a minimum requirement in the DC Energy Code, also has additional options for the Green Code, also can help you comply with stormwater and green area ratio requirements. Those will have an impact both on your code compliance and your BEPS, as well as potentially some of these other DC policy areas. Okay, long-term planning, aside from the generic, what's in the code, how can it help you comply? We have done some other analysis, not related to BEPS, but just sort of related to what are sort of targets that may be able to be approached for new construction and for existing buildings. And so this is a chart combined with some analysis that MBI has done, as well as some analysis that Stephen Winters Associates has done to say, new construction, what do we think is sort of a zero energy target, or like as a sort of optimized building, how much can we reduce energy use intensity in new construction across different building types, and then comparing it to, at the time when we did this, 90.1 2016, what would the code have given you? And then match this up alongside some analysis that Stephen Winter I did around how can you sort of optimize existing buildings in the climate zone, and what would a comparable ASHRAE standard give you? And so that we were looking at standard 100. And so you can see that often, but not always, those optimized buildings will present a better performance. And so if in your new construction, you are always targeting the lowest energy performance possible, you are setting up for that long-term compliance with BEPS. Additional sort of beyond code considerations, transportation infrastructure. We talk a lot about electric vehicles, increasingly. And so one of the key things that I want to point out is that if you are putting electric vehicle chargers into your building, it's going to be very important to sub-meter that load. I think we just saw this come out in Boston's building performance standard release, that the only way to subtract electric vehicle charging out is to have it sub-metered. So I would really strongly encourage any electric vehicle infrastructure to be sub-metered. That is not a code requirement. It is going to be a best practice for you to get those loads out. It will impact your Energy Star score. Distributed generation, rooftop solar, like we just said, is partially a code requirement, is partially helpful in meeting other district policy requirements. Grid integration, focusing on real-time energy management. So having the building automation system and other controls in place to make sure that your building can respond to utility signals, may or may not lower your overall energy use, but it will set you up in a way that you can have better control of the building overall, which should help the operations. And then making sure that operator training and new guidance is given at building delivery. Again, there are some requirements in the code around commissioning and things like that, but operator training is not a code requirement. This is a graph that the hub has put together for how you may consider electrification for system retrofits. And so I'll sort of rely on the hub to, decide if they want to talk about justification necessarily for possibly just maintaining natural gas systems. I would say that as we are looking increasingly towards, Linda mentioned COP, NBI has been looking at what it means to electrify our buildings and the impact that we have. Having a new natural gas system is going to survive for another 20, 25 years. And so, an acceptable payback equation here may not be taking into consideration of potential carbon regulation. So I would try to drive everyone to make the switch to electrify, knowing that it may not actually pencil out in terms of BEPS compliance. So while I'm going to try to cap this at just a couple more minutes and leave some time for questions, electrification considerations that seem to be really important in the new construction space. I mentioned this a little bit before: performance path, the baseline building. HVAC, office uses a VAV, multifamily uses a PTAC. Both of those are electric. Water heating, the office uses electric resistance, the multifamily uses gas. In terms of Appendix G, because it is based on cost, that gas impacts cost savings when you switch those buildings to an electric water heating system. That's the code piece. Energy Stars in a negative way, right? So switching from, maybe I should just be more pointed on that. A multifamily system that has an electric water heating system is going to be less code compliant than a multifamily building that uses gas water heating. And it's something that we're working with the district to address in its next energy code. The Energy Star score uses a source energy conversion factor, but it uses national factors. So when you look at your Energy Star score and that source energy, it's not based on the cleanliness of DC's electric grid. It's based on the national average of the electric grid. So we're not fully accounting for carbon or the benefits of electrification in either the code or the building performance standard. So when we took a look with another group that was looking to build a new multifamily building in DC, we went through a couple of options and I know this is a little chart, maybe doesn't mean all that much to anyone, but they tried a couple different options for moving things to electrification. So they tried to put in a water heating electric system and a space heating gas system. And we can go into what these mean one-on-one, maybe with some of you a little bit better. But what this shows across the bottom is how code compliant the building was. So just using the 2017 current DC code, the building was negative 29% compliant, which means not compliant, right? You need to be over 0. Using the new version of ASHRAE 2019, still we were about 11.5% non-compliant. If we used a carbon building performance factor, which is a way to calculate your the way the ASHRAE is now using to calculate the energy code compliance under Appendix G, sort of just barely eked out. And then if you looked at using site energy, you were compliant, right? 3.3%. And that same multifamily project, though, with an electric water heating design, got an Energy Star score of 88. gas water heating design got an Energy Star score of 95. So this building, again, this is a single building. It is not necessarily representative of all the considerations that we've been talking about here today. But the important thing to remember and to take away from this is that how you calculate code compliance. Again, these are 4 different results, same building, just based on the calculation method that we use. 2 different results, same building, swapping out the water heating system is going to change your Energy Star score. And I would say in a way that this 95 is going to ensure long-term compliance, but discounts the impact of the carbon being emitted. So you're in sort of a tricky place in the district right now. And I don't want to underemphasize the fact that these numbers are coming up in the ranges that make it a little bit difficult for you all to do your jobs very well. And with that lovely note, I said at the beginning, we had resources. The hub has put out a series of wonderful resources on BEPS and electrification and trying to understand what it means to be building and renovating in this district. NBI, we are constantly updating our resources, both through tracking buildings, on our Getting to Zero database, as well as putting out new targets and other metrics for building owners and designers to consider. And then a series of other resources from national and international sources that we also think are really good at driving people towards zero emissions, zero energy, and both new construction and retrofit. So with that, I will turn us back over to Q&A.
Thanks, Kim. We haven't had a lot of questions here, but I did want to read out one comment that says, thanks, Kim, great content that paints the reality of developing in DC right now. It's fair to summarize by saying a, quote, compliance only mentality in DC now is not going to cut it. AEC industry needs to make the switch from a compliance to predictive based approach with all of our eyes set on net zero energy. So I will agree with that statement and say that, there's a lot of change happening. I think we're all, we're almost a year into this first BEPS cycle, but things will continue to change and we need to continue to push and think about, net zero and obviously the bigger picture here. So there is one question that just came in for you, Kim. If gas is favorable for both code compliance and Energy Star score, and therefore BEPS, how should we try to continue to push electrification and carbon metrics?
Well, a couple things. NBI is pretty involved in DC's next code update, which I know doesn't solve everything for everyone now. But we are therefore also pretty close to the people that are reviewing your buildings as they're coming in. I would recommend if anyone has a building that looks in a bizarrely similar situation to the, sample building I just showed, there are public proposals for the next DC Energy Code that involve those site EUI and carbon building performance factors. And we have been sort of given a soft nod from DCRA that says that if a building were to come in under the 2013 cycle and wanted to model using different building performance factors, that they would consider those through a code modification request. I would be happy. You all should have my email address. It's kim@newbuildings.org to help anyone sort of work that out and figure out how to make that happen if the concern is just getting code compliance with an electric building. We can help you make the case to say that this is the same building. This is strong code compliance. This is not an energy code deficit. For BEPS, it's a bigger question. We don't know the future Energy Star targets, right? So if I was designing a new building and my owner came to me and said, like, I want to be very future-proof against BEPS, that 95 looks a lot better than an 88. Although they're both over, the 75 for Energy Star score. We don't exactly know what DC median will continue to be. And if, DOEE will ever sort of consider shifting to a carbon metric, or how Energy Star will renormalize, or if EPA will start to look at local grid conditions instead of national grid conditions. So it is a tricky piece to this puzzle. I would say that based on the district's goals from the very beginning of this, carbon neutral by 2050, you cannot be carbon neutral in 2050 and be combusting gas on site. There has to be a way towards BEPS compliance that, Teresa, whatever you just said, I should have written down that person wrote, although I'm sure it's still in the chat. We can't be so focused on compliance that we're giving up on performance. And performance has to include combusting fossil fuels on site. I don't know politically how to make that argument for you all. I don't know how to navigate a BEPS waiver or whatever is happening. I think that building that I showed, that new construction building, luckily has a few cycles before it's at risk. But there's got to be a conversation that is had around the impact of gas in these equations.
For sure. We do have one more question. So for the prescriptive path, there was a note regarding energy type metering. Is this required for HVAC versus lights versus plugs at a building level, or is this down to tenant levels as well, similar to local law, NYC's local law, A8?
I'd have to flip open the exact requirement. So it's a threshold based on either load or size. And so it is not at the tenant level unless the tenant trips one of those individual metrics. I'm like trying to find my chart right here while I'm on the phone with you guys. But it does need to be done at the whole building level. And that requirement is based on size of the building or size of the load. And I'm unfortunately not quickly finding it. If I find the code section while we're on the phone here, I'll cite it to you.
There's a few comments.
Teresa, you might know. You did code.
That sounds about right. But again, there's so many nuances. We'll definitely, I'm taking note of this question and
Okay.
we'll follow up with the specific.
I will get a specific answer to this person.
Yeah. Let's see, we have a few more questions coming in here. Is it difficult to gain green approval or
PTAC? If you're doing a performance path, right? The PTAC is the baseline in multifamily. The problem with building things to baseline is that then something else has to either exceed baseline because you're going below something else in the performance path. So is it difficult? Depends how your modeling turns out, but I would say probably. I not a mechanical engineer. I don't know that we should be using a lot of PTACs anymore. There are better efficiency options out there. It's going to get you a code compliant building, probably almost certainly under some configuration. It is not going to set you up, like I said, for that long-term compliance for BEPS because it is not the most efficient option that is out there. So your mechanical system is going to be hurting you long-term compliance. Also, again, individual operators are going to potentially be part of your downfall. So every individual with a PTAC is going to be able to set it to whatever they want. That energy use will be totally unregulated at the whole building level.
And it looks like we have one final question. We might have time for one more. So if you have any other questions, please put them in the chat. This is a two-parter. It says, for existing buildings, under what circumstances would an old building working to comply with BEPS be forced to bring the entire building up to current electrical and fire codes? And could a deep energy retrofit trigger the need to bring an old building up to code, drastically increasing project costs?
That's a really good question. Could a deep energy retrofit force compliance with the entire code? Sure. I mean, if we're just talking right, like there are multiple ways to do a deep energy retrofit. Some of them may trigger compliance with fire code upgrades, accessibility upgrades, other requirements. You would need to track it very carefully through the existing building code to understand if you have tripped over into being from a level 2 alteration to a level 3 alteration. There are even some energy upgrades that are level 1 alterations, right? So it just depends on how your work is classified, how it would be sort of staged over time. You know, if what I'm saying doesn't make sense to you, hopefully it does to whoever is asking this question. It is possible, yes. It is also possible the answer is no. I would try to work closely with a specific code consultant that can help you answer that question and do some of those calculations early as you're sort of planning out your project, so you know the potential for cost and what those other implications might be.
I think that's all the questions we have. If there aren't any other questions, Kim, could you pull up the hub member slide, please? I wanted to give a quick shout out. So before we wrap, I want to give a big thank you to all of our hub members. You can see we have quite a few. They are the members that are helping to support the Building Innovation Hub develop resources and deliver innovative content and educational opportunities and peer-to-peer connections like the one today. So we really appreciate their support. And we are also continuously looking for more members. So if you're interested in your organization becoming a member, certainly reach out. I put my email in the chat, but we will also follow up, and there's Kim's information. We will also follow up, like I said before, with an email with the recording and links for more information. So unless there are any other questions, I think we can go ahead and wrap. And again, thank you so much, Kim. Thank you, Linda. And thank you, everybody, for joining us today. We'll be in touch. Bye-bye.